Hello, and my name is Marcus Levy, and I'll be your host today for this webinar, Understanding Concurrency, Performance Optimizations, and Debugging for Multicore Platforms. I'm President of the Multicore Association and Chairman of the Multicore Developer Conference, which will take place next May 2013 at the in Santa Clara. I'm also founder and president of another industry consortium called Embassy. I'll open the webinar today with a brief description of the Multicore Association, although hopefully many of you are already quite familiar with what we do and our mission. The main presenters of today's webinar are David Stewart and Rob Oshana, co-chairs of the Multicore Programming Practices, or MPP, working group. David is CEO and co-founder of Critical Blue, a company that develops and distributes software solutions and associated services for migrating existing software applications onto Multicore platforms. Rob is the Director of Global Software R&D for Networking and Multimedia at Freescale Semiconductor, and he's also a distinguished member of the technical staff. David will start off by describing the motivation behind the formation of the MPP working group, as well as providing a basic background on the composition and construction of the MPP book. Then Rob will jump in and show how Freescale validated the content of the MPP by applying the techniques directly to a case study drawn from a networking application. The Multicore Association was founded in May 2005, back in the pioneering days of multicore technology. To this day, the primary goal of the MCA is to develop an extensive set of application programming interfaces and the establishment of an industry-supported set of multicore programming practices and services. The consortium hosts three types of memberships, including board, working group members, and university members. Naturally, if your company isn't listed here, we'd like you to join, or more precisely, we need you to join to help us ensure that we can continue to develop well-rounded and optimized specifications to increase your time to market with multicore related products. Now, up to this point, the Multicore Association has completed three primary projects. By far the most popular is the Multicore Communication API, or we call it MCAPI. It's a message passing API for synchronizing and communicating between processor cores. It can even be used to connect threads or processes in a shared memory environment. It's usually under the hood of an embedded application, but we're doing our best to make the world aware of the growing number of implementations, so check out the link on our website. MCAPI can provide a low-level layer for higher-level programming models, and you can read about this in a recent article published on embedded.com. The title is What the New OpenMP Standard Brings to Embedded Multicore Software Design, so just do a Google search for that. We've also completed the Multicore Resource Management API, which, among other things, is used for managing shared resources in a closely distributed embedded system. Both MCAPI and MRAPI can be applied to homogeneous or heterogeneous systems. And for the main reason that you're here today, we will be unveiling our Multicore Programming Practices Guide, 120 plus pages written by committee and dedicated to various multicore programming techniques. We currently have three active working groups covering a range of multicore development technologies. And mechanisms exist to support tool interoperability for embedded applications that utilize a single IDE, but you realize that no standard exists to support the embedded multicore environment. A huge problem in the industry today is development tool interoperability, especially when it comes to working with SoCs containing a variety of heterogeneous cores. This is an area that the TIWG is focusing on. The TIWG is also collaborating with the CE Linux Forum to produce a de facto trace data format standard. The Virtualization Working Group has devised a scheme to categorize the different virtualization features provided by today's multicore processors. This will ultimately help system developers select the processing solution that is best for their applications. We have a first draft complete, So let me know if you're interested in reviewing this. You can contact me directly, and we'd like to get your feedback. And last but not least, the MCAPI working group is devising a clever API to support the coordination of tasks on embedded parallel systems, both homogeneous and heterogeneous. Some of you may have been involved in our external review process, and we thank you in advance, and we're hoping to release this API before the end of the year. Ultimately, the three APIs I've highlighted here will provide a foundation for a multitude of services and functions, including load balancing, power management, reliability, and quality of service, elements that are also on the consortium's roadmap. Software development tools will be able to take advantage of the unified APIs and standards independent of specific multicore systems. And now, for our feature presentation, I'll turn it over to Mr. David Stewart.
Thank you, Marcus, for that excellent introduction. What I'd like to do in this section is to tell you a little about the history of the MPP working group. I'll explain how and why it was set up, what the objectives were at the start. I'll talk you through how we ran the group, and then finally show you some examples of what's included in the MPP guide. I hope by the end of this section you'll be very keen to get your hands on this new guide. The next few slides are actually from a presentation that I gave to the Multicore Association board, proposing the setting up of a working group to look at multicore programming practices. At Critical Blue, we've been looking at, we've been providing tools and services in the area of multicore, programming multicore platforms for a number of years. We saw the introduction of many different variants of multicore architectures, and we saw people trying to program them using the existing languages and using existing techniques, not recognizing that the introduction of multicore platforms is probably the single biggest change to software programming that there's been since the introduction of the compiler. We recognize too that tools were not enough. Just introducing new tools that understood multicore architectures may not be enough to help product companies be successful introducing new software on these new multicore platforms. We recognize that there was an element of education required in order to make sure that software developers learned new techniques and that the same mistakes were not made over and over again. And these were some of the guiding principles that pulled us together with this idea that perhaps we should try to build some sort of industry guide to help people through this transition. This slide talks about what software developers really need in order to be effective with multicore platforms. One of the first topics that comes up in this area is programming languages. It's certainly true that for parallel architectures, new languages and methodologies might be appropriate, but it's unlikely that any of these are going to become mainstream in the next few years. So what we decided was that what would be sensible would be to focus on today's embedded C and C++ code, because most of the existing legacy software is captured in those languages, and that most people looking to move to multicore will be migrating existing software applications. So this is the state of the art today, and we decided that the MPP guide should really be focused on that area. But how would we manage to pass on the information as to what the best approaches should be for programming these architectures? And what we felt was the best way to move this forward was to pull together a group of experienced individuals from the industry who had been through this process themselves, who had adopted multicore platforms and launched successful products based on existing C and C++ code being used on those platforms. There are plenty of examples of such products, and we knew there were many interesting lessons that could be learned from that. Paraphrasing Sir Isaac Newton, we planned to stand upon the shoulders of giants in order to see what we needed to see and in order to build a best practices guide that would be useful for software developers across the planet. The Multicore Association was an excellent place to find experts who had been through the process of transitioning into programming multi-core architectures. So I was delighted when the MCA board approved the proposal to create the Multicore Programming Practices Working Group, and I was pleased to become the chairman of that group. This slide summarizes the high-level agreement that we made on that day. As I mentioned, we'll be focusing on standard languages, C and C++, without any special proprietary extensions. We also decided that we should not be tied to any particular processor architecture or indeed any particular multi-core platform architecture, and that we try as much as possible to make the guide focus on general programming that could be applied to any particular processor or multi-core architecture. The biggest issue with people who had been trying to program multi-core in the past is that they tended to make the same mistakes, and fear of making those mistakes sometimes even prevented people deciding to use multi-core in the first place, and we really wanted to avoid that. So we wanted to focus on identifying common mistakes that are made when programmers transition into or onto parallel architectures, but not just point out mistakes, but consider solutions, but also consider how programming migration could be done to avoid such things. Also, the use of multi-core platforms introduces a new class of bugs that you don't see on single core solutions. So it would be important to explain those bugs, how they occur, why they're a problem, and obviously also introduce some ideas about how they can be avoided. And this is the Multicore Programming Practices Working Group mission statement that was agreed upon following the decision by the MCA board. Most of the concepts in this text I've already mentioned. The only thing I would add is that the idea of the guide was that it would be very practical and easy to use and be full of examples, so that it would be easy for software developers to make very practical use of it. I'd like to talk a bit now about how we ran the group. As I mentioned earlier, Critical Blue had been working in this area for some time, and in the course of our training and on-site consulting activities, we had pulled together a collection of examples of the kinds of things that we saw at customer locations, and you know, some suggestions about avoidance tactics that we had proposed in the past. And we decided that this might be a good starting point for the MPP working group. So we made a contribution of all of that body of work, and it was in no way a completed guide, but it was a series of examples that could be picked through by the experts that we were assembling, and would perhaps provide some initial inspiration for how we would organize ourselves. So we went forward on this basis, and we started to have regular phone calls. We met for an hour every couple of weeks, and we started to divide up the task and get volunteers to propose themselves to lead various different parts of the guide itself. And typically what we did was we had a chapter which was written by 2 or sometimes 3 different people from different companies, and we went through a process of doing a high-level overview of the chapter and then diving into more details with examples. And in each case the material came back to the whole group, and we reviewed it as a whole, reached conclusions on changes that needed to be made, and went through that iterative process chapter by chapter until we had completed the guide. Then of course we did a further review of the completed guide to make sure that it held together as a completed document. As you would appreciate, writing styles are different from different people, and so there was some work required in order to try to make the whole document speak with a single voice. But I think we've achieved that now, and we have a very nice document that I'm sure you'll enjoy reading when you get access to it. Now, this is actually a list of the main chapters in the MPP guide itself. Terminology and a review of existing technology was very important, I think, to set the context to make sure that we're all speaking about the same things when we use certain terms. When getting into the actual software development process itself, we basically cut it into two, and we looked at high-level implementation design issues, as well as the lower-level implementation consequences of that initial analysis. And then the two other areas that we focused on in some detail will probably not be a surprise to you, but one would be debug, as I mentioned. Parallel architectures or programming parallel architectures has the potential to introduce some new kinds of bugs that you may not have seen before. And secondly, the way you use the resources available to you on a multi-core architecture can have a strong impact on the actual performance that you get. And sometimes the performance is not directly linked to the use of compute resources, but it may be linked to the use of memory resources and buses and things like that. So there are a number of different performance areas that you need to look into and take care of to make sure that you get the best possible return from your investment in a multi-core platform. And this is just an example of a couple of pages from the MPP guide itself. And the main point here is just to illustrate that the guide is not just dusty text, but we also include graphics to help understand some of the concepts that we want to get across, and also that there are many code examples which are very good for showing the way to introduce problems and also the way to avoid them. And so I just wanted to give you an example of the kind of thing that you'll see inside the guide itself. So in summary, while we wait for a potential new parallel programming language to come along and make life easy again, there are successful products to build, launches to make of new concepts based on multi-core platforms with software, and that software will be written in C and C++. The MPP working group was set up to help in that process by sharing best practices from previous projects in order to encourage, to inspire, to motivate software developers to get the most out of the silicon platforms which are out there based on multi-core architectures. And the objective of all of that was to produce a guide which would be a first step to make sure that we raise the bar of knowledge on what it takes to program multi-core platforms and what are the best techniques to use in order to have the best possible experience. And with that, I'm going to hand over to Rob, who's going to talk about an example of a real project which has applied MPP principles. Rob.
Thanks, David. So now let's look at a case study. We're going to look at a IP forwarding application. This is a router application. This is a application that an engineering team worked on using some of the MPP guidelines. This is a system. This routing application is can be partitioned into control plane and data plane processing. The control plane runs control protocols. It provides management capabilities, error reporting, things like this. The data plane does a lot of the real-time processing for the data packets. It's all about taking data packets in, doing some processing as quickly as possible, forwarding them on to a destination. This is a example of that here. This is a routing type algorithmic pipeline. The Ingress pipe receives packets. We do some protocol checking, table classification, some hash tables based on 5 tuples, and to help get the proper ID and determine next steps. Some table lookups, ARP lookups. We do some additional processing modifications in queuing, and then the egress pipe includes scheduling and grouping, traffic metering, and quality of service type functions, and then sending those packets on their way. It's a typical IP forwarding type of an application, but one that has to run on a multi-core processor divided into both control plane and into data plane. The case study followed very closely Chapter 3 of the MPP guide. The application ran on a single core processor. We had to repartition the application and optimize it to meet our performance goals. Performance was a very significant non-functional requirement. The team was asked to meet a high bar as far as performance on this multi-core part. The team followed the MPP guidelines called out in Chapter 3. In the flowchart is kind of shown here. Follows a prepare, measure, tune, assess flow. The application was essentially gone through an initial type of a partitioning. Performance was measured. It was not acceptable. A set of tuning processes were then undertaken, and of course those tuning processes went through iterative regressions. If those regressions did not pass, we had to go back and back out those changes, but we'd rather do it earlier rather than later. If they did pass the regressions, we'd do another measurement. Most cases we got better. In some cases we didn't, and we'd have to go back and do some changes. This is the typical iterative nature of optimizing many embedded systems, and also for multi-core it's even more important that we follow this type of a process, especially on the assessment side. If those measurements did not meet the goal, they were not good enough yet, we iteratively went back and looked for other tuning opportunities. If they were good enough based on the defined goals, we called ourselves done, and we went on to the next step. But Chapter 3 in Programming Practices guidelines were very helpful in guiding the team, some of which were experienced, some of which were more novice. Got them all on the same page as far as process and technique in order to go map this complex application onto a multi-core device. So what do? We analyze the customer application, partition that application in a rough way onto the multiple cores. We look for areas of parallel optimization and parallel mapping, as well as pipeline operations. There was both that existed in this IP forwarding application. We then measured the performance to see if that performance is what we expected it to be, and that required some iteration as well. We had some partitioning problems that we had to go take care of. We collected debug information and statistics to locate those bottlenecks. That was very important that we had the code instrumented properly to collect that debug information and statistics. Without that, we would have been really blind as far as locating some of the key bottlenecks that existed in the application. Did a lot of fine-tuning on step 5. We fine-tuned the partitioning design. We had to do some things at the lower levels, spin locks and things like this, based on the above collection of this debug information, and we used that to help us eliminate those bottlenecks, and we did that iteratively. We had to make, on step 6, a very intelligent use of our data path acceleration capabilities. The device we were using had a lot of network acceleration. Those network accelerators can be configured in many ways, used in different capabilities. We had to intelligently use those as far as configuration, which parts of the algorithms we were going to accelerate and how, in order to look for further optimizations. Very important that we leverage those accelerators as we went through this. After several iterations of this, we did actually meet our performance goals, and we concluded the exercise. It took us probably more than several. Actually took us many iterations over several days for this application, but again, following the standard process and steps, outlined in the MPP, we were able to take this to a successful conclusion. So before we applied the MPP guidelines, we did a very high-level multi-core partitioning, both on the Ingress and the Egress sides of the algorithm, if you will. On the control cores, again, that's where we put some of the management and authentication, some of the protocol type processing and configuration. On the other cores of the device, the Ingress and Ingress and Egress were both partitioned into different core groups, and each of those core groups had a set of algorithms allocated to it, as shown here. We had some common data structures and common acceleration type infrastructure, the frame manager, the buffer manager, and queue manager at the bottom that interfaces to our Ethernet ports. Those were they were leveraged. Those are hardware accelerators that are essentially, they help us manage queues and information passing between the cores and the accelerators, and they also do some hardware scheduling for us. So we were able to leverage that capability on the device, and so it required some partitioning in order to leverage those accelerators, some common data structures in the soft queue. But that was the rough partitioning that we did initially. The performance results are shown here. Without going into a lot of detail, look at the totals as far as the modules. On the Ingress and the Egress, we rolled up the key the key results, instructions, and cycles, and we summarized those. Those are shown here. We were able to leverage some of the work that we had done in the debug area to identify those bottlenecks, and also to record some of the cycle counts, and those were very effective at helping us roll up these numbers. After applying the MPP guidelines, the multi-core partitioning changed a little bit as far as the Ingress and the Egress. By identifying those bottlenecks, following the guidelines, iteratively going back, we repartitioned some of the application onto the Ingress and Egress core groups. We still leverage the frame manager, the buffer manager, and the queue manager, but we were able to repartition the application in such a way that we got a better balance across the different Ingress and Egress core groups. And as a result of this, after the repartitioning, the cycle count has gone down. We're able to achieve higher performance results after the repartitioning, again, after following the guidelines, and that ended up being very, very helpful, again, for us to take this to a nice rapid conclusion by following a defined process and using defined techniques from the MPP. So the conclusions, the key things: partitioning and optimization of multi-core software requires a very disciplined process. You have to go about it in a disciplined way with a plan, a process, a set of techniques to identify the key bottlenecks and to optimize those, as well as partition the application and get you that best performance. It was an iterative approach to achieve, in order for us to get completed sooner, get faster time to market. The iterative approach had to be managed in a disciplined way. What I call time to performance goals. We did not go past our performance goals. We did not do excessive optimization. We did just enough to allow us to get to market. And then the Multicore Programming Practices from the MCA did serve as a very useful guide for the development team, not just in this one little section of this story, this case study, but really in all phases of multi-core software development. The team not only had to partition and optimize, but also had to do a lot of development, initial development, and then on the back end, more system integration. So the MPP did serve as a very useful guide for developers involved in really all phases of multi-core software development.
Hey, very interesting, Rob. Thanks a lot. So in conclusion of this webinar, and actually before we get into the Q&A session, let me just remind you, if your company's name is not on this list, feel free to contact me directly. We'd like to see you involved with this consortium to help us to continue to develop industry standards for progressing multi-core platforms. So thank you very much for attending, and now's the time you can start plugging your questions into the Q&A box, and we'll try to answer as many as possible in the time that's remaining. In case you want to listen to this webinar again, we will be posting it live. It should be available in the next couple of days, and we'll be sending out an email reminder just to let you know when it's there. So thank you. So the technology, which would include some heterogeneous and homogeneous processors. So Rob, do you want to address that?
Yeah, Marcus, you had cut out there for a little bit. I lost a little bit of sound.
You want me to repeat the
yeah,
question?
Please.
Yeah, so if you're putting out a general purpose document on multi-core programming, how do you get it to so it's adopted for both heterogeneous and homogeneous architectures? I mean, are the techniques in there applicable to all aspects?
Okay, yeah. So what we found was that they really were. For example, in the specific device we applied this to, it was it had 8 homogeneous cores, plus it had some heterogeneous type acceleration, and the guidelines were, in a sense, general enough that we could use them as a framework to begin to outline the process. Of course, as we got more kind of device specific on some of the acceleration configurations and techniques, we had to obviously get more, we had to customize that more to our specific device. But one thing that I think one of the biggest benefits that we took out of it was the development teams that were the ones that were going to different customers trying to accomplish the same kind of goal of partitioning and optimization, using the guide as a framework for how to approach the problem. And then we actually used kind of a fact list, almost like a frequently asked questions list between the teams to share information about how to do more of the hetero-specific type optimizations as we ramped up this process. But the MPP served as a great framework to allow us to approach it consistently across the different development teams.
Cool. Thanks, Rob. So there's a couple questions in here that I could answer really quickly. It's asking about when the MPP document will be available and where. We will have it available on our website, and we will send out a notice to all of you who attended this webinar so you can go download a copy. And the price, well, it's extremely affordable. We've priced it at $0. So you just have to click on you'll have to click on just a license document, pretty simple, and you can download it and have free access to it. Another question about the contact info of the speakers. I'm not sure if the other guys want to give out their details, but if you go to the Multicore Association website where the URL is listed here on this page, you can find my contact info, and if you have specific questions for the speakers, I'll forward it on to them. So let's see. Does the MPP guide go into detail on tools and techniques for instrumenting code and taking measurements? And David, do you want to address this one?
Sure, I can do that. Actually, we went to some lengths to make sure we didn't go into details of specific tools because we didn't want to prescribe a particular tool flow. That wasn't the objective of what we were trying to achieve. So we wanted to explain techniques and methods which would almost be independent of the tools, so they're more like processes and the way you go about things. There are references made to various tools within the MPP guide, but only really in passing. And we felt that if we started to mention particular either open source or proprietary tools, then of course we would have to mention them all, and then of course we would have to do some sort of comparison between them, and that really wasn't the objective of what we were trying to do. So what you'll find in MPP is approaches and guidance, and then, as I say, some references to tools. If there's specific tool areas you're interested in, then by all means get in touch with me, and I'll be happy to guide you to open source tools or proprietary ones if there's specific problems that you'd like to investigate. Certainly the issue of measurement of results is an important one. And so we recommend ways in which you can improve things, but we don't specifically recommend ways of measuring where you are today and where you are tomorrow. But as I say, if you get in touch with me, I'd be happy to give you any advice I can on that.
Okay, thank you. Another question, and this one can be either for Rob or David, is MCA working on some verification techniques, methods, or tools for multi-core programs?
Well, I can have another go at that too. One of the things about MPP was that it's a little different from the other working groups that MCA has, in that it's not trying to set up any particular standards, although that was actually something that we thought about at the beginning and is something we may come back to. The idea was that some of the guidance in MPP could over time migrate into some specific standardization efforts. With respect to things like verification, there are within MPP references to verification, and of course one of the most important things is to understand exactly what you're verifying. So what we did was we took a real ground-up approach. So for example, we don't assume that the reader knows what a data race is. In fact, a data race is one of the best examples that I use of a situation where everybody uses the term data race and everybody nods their head sagely as if they know exactly what that means. But in our experience dealing with customers, quite often they don't really have a clear understanding of what a data race is, why it's a problem, and most importantly, what to do about it. So so these kinds of things are absolutely mentioned in the MPP guide, but from an explanation of what a data race is and then through to what you should do about it. Verification techniques are a step beyond that, but certainly we will recommend ways in which you should establish whether you have data races, and if you do, what you do about them, and if you're coding for the first time, what kind of techniques you can use to avoid having them in the first place.
Okay, and I see another question here. Let's see, any optimization techniques? Are there any optimization techniques to meet the time latency in the C language in the multi-core framework? And either David or Rob, you can address that question.
Well, I'll say a couple things. There is a lot of discussion in the MPP on different types of optimizations at different levels, whether it's guidelines on things like affinity scheduling or different types of things like aligning computation locality. There are a lot of very good guidelines with some very good examples on techniques like that, and but the guide doesn't get very specific down at the device level, obviously, but at the system level, I think it does a very good job of pointing out a number of different optimization approaches with some very good examples. I'll let David comment as well.
Yeah, I'm not sure I can add a lot to that. I think that's a good summary of it. Time is considered in the large, if you like, rather than down at the cycle level. So we're discussing, how you schedule things and how you should make use of concurrency rather than going down to a much lower level.
Okay, and I'll take another question here. I'll answer this one in short, and then if you guys want to expand on it, you can. So does the guide deal with techniques for SMP, AMP, and virtualized solutions? So the guide does not take on virtualized solutions, but it does focus quite a bit on SMP and AMP, as well as with and without operating system support. So bare bones, as well as, for example, with Linux and threading techniques. Anything else from you guys?
No, you just demonstrated, Marcus, that you have in fact read the guide, which is good.
Cool. So just a final reminder that the whole webinar in recorded format will be available from our website, multicoreassociation.org, and we will also post the slides, and then we'll have an FAQ that's available. So actually, a couple more questions have come in. Are you proposing language extensions for Multicore in C and C++? And I'll let one of the other guys address this question if they want.
Yeah, the answer is no. In fact, as I mentioned, we actually deliberately avoided any language extensions. This would be part of this is something that could be considered later and would be part of a standardization effort if this was a direction we wanted to go in. But in general, there are a lot of language extensions and class libraries and all kinds of bits and pieces you can use. But the problem is they typically tie you to a particular tool chain or perhaps a particular silicon platform, and we really wanted to avoid that. We wanted to provide some general guidelines that would work with independent of your tool decisions and independent of your silicon platform or even your processor decisions, because those are the most useful types of examples and guidance, we thought. So yes, I'm sure the working group has ideas about, I'm sure they have a diverse set of ideas about potential language extensions, but this is not something that we considered at this time. But as I say, it could be part of a standardization effort later on if there was a interest in doing that.
Okay, and I might add to that this whole Multicore Programming Practices guide was based on a lot of volunteer hours from amongst the members, and certainly we'd be looking to entertain, if this one is successful, to entertain doing a version 2 of it. And any of you on this call, if you're interested in participating and adding in what you think might be important to help proliferate this knowledge, again, feel free to contact me, and we'll see about how to get this thing going for second phase. And sorry to repeat here again, but another question came in about when the MPP guide where it's going to be available. And again, we'll send out a notice to everybody on this webinar, and it'll also, when it's done, it will be posted up to the MCA website, so you can click and download it. Okay, Rob, do you want to add any closing remarks?
No, I'll just say that this is a very practical guide. It has demonstrated utility solving real-world problems, and Marcus, I look forward to using this more broadly across my team, and so thanks very much.
Yeah, and I mean, I did read the whole thing from cover to cover, and I have to say that it is a very good educational document, and it covers a wide range of technologies from beginner level to fairly advanced level. So I think, there's something in there for everybody. Yeah,
written by practitioners for practitioners.
Yeah. So without belaboring the ending here, I'd like to thank everybody for coming on to this webinar. We'll be in touch with you shortly with updates on availability of the document. And again, feel free to contact me directly with questions to me or to the presenters, and I'll be happy to make the contact for you. Okay, so thanks again. Talk to you on the next one. Bye-bye.